All right, one that's a little more difficult. Number 5 says find the equation of the function with integer coefficients whose zeros are 3, 1 plus I root 3 over 2, and 1 minus I root 3 over 2. So if I add these all up, I'm going to get negative b over a. Now the nice thing about adding these up, I always deal with the imaginary ones first because they have a tendency to cancel out. 1 on 1 is 2. I root 3 minus I root 3 dropped, so I get 2 over 2. 3 plus 2 over 2, or 3 plus 1 is 4. So 4 is negative b over a. If I pair them up, 3 times 1 plus I root 3 over 2 plus 3 times 1 minus I root 3 over 2 plus 1 plus I root 3 over 2 times 1 minus I root 3 over 2. I'm going to get c over a. Distributing, I get 3 plus 3I root 3 over 2. Distributing here, I get 3 minus 3I root 3 over 2. And just dealing with these two, 3 and 3 makes 6. 3I root 3 minus 3I root 3 cancel, so I get 6 over 2, which would reduce to 3 if I wanted to. We'll see what happens here. Now keep in mind, we're going to keep this answer separate because I want it for the next one. First times first is 1. O's and I's drop. Outside times outside. Positive times a negative is negative. Root 3 times root 3 is 3. I times I is I squared. Over 2 times 2, which is 4. But 1, or I squared is a negative 1, so I get negative 3 times a negative 1, which is a positive 3. So this becomes 1 plus 3 over 4, or 4 over 4, which is 1. So I have the 3 from here plus 1 from here gives me 4 is c over a. And then finally, if I multiply them all, which the first 0 is 3, and the second 0 turned out to be, these two zeros, I mean, when multiplied, turned out to be 1. 3 times 1, or 3, is negative d over a. So looking at all three of these, that one there, this one that I just did, and this one here, without a denominator, a is 1, a negative b is a positive 4, so b is negative 4, c is 4, and a negative d is a positive 3, so d is negative 3. I get f of x is a, which is 1, x cubed minus 4x squared plus 4x minus 3. And that function will have those 3 zeros.